Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe and press the bell icon near the subscribe button so that you get the notifications of my latest videos, and do not forget to like and share the video. Today we'll be solving the questions from the chapter Light, Reflection and Refraction. And we'll be going with the exercises. This belongs to physics part. Now we'll be going with the question number 7, because we have already completed the 6 questions, the previous 6 questions in our previous videos. The 7th question is, we wish to obtain an erect image. The question is a bit lengthy, but the answer is very simple. Of an object using a concave mirror of focal length 15 centimeter. What should be the range of distance of the object from the mirror? What is the nature of the image? Is the image larger or smaller than the object? Draw a ray diagram to show the image formation in this case. So the question is this big. Let me read the question again. We wish to obtain an erect image of an object using a concave mirror of focal length 15 centimeter. What should be the range of distance of the object from the mirror? So the given part is this. This is given. Now asked. What is asked? First question is this. The second question is this. The third question is this. And finally, this is our next question. So in one question, see, there are too many questions asked. What should be the range of distance of the object from the mirror? What is the nature of the image? Is the image larger or smaller than the object? Then after solving all these questions, we are asked to draw a ray diagram to show the image formation in this case. So first we'll be going with whatever is asked, whatever is given. See, first what is given? There's a concave mirror and the focal length of the concave mirror is 15 centimeter. So we write that first, okay? solution. The focal length is also represented by the letter small f. Focal length is plus 15 centimeter or minus 15 centimeter. It is minus 15 centimeter. Apply the sign conventions, new Cartesian sign conventions, and you will find that focal length of concave mirror is minus. So it is minus 15 centimeter over here. The first question is, what should be the range of distance of the object from the mirror to obtain an erect image? In the sense, virtual and erect image. Recall the ray diagrams. Now in the last ray diagram, if you recall, you would remember that this is the concave mirror we studied. This was a principal axis. Let me just draw a rough diagram. This is the pole of the mirror, principal focus. This was the center of curvature. And in the last ray diagram, we saw that this was our object. Then this was the first ray, which comes from here, somewhere here. Then the second ray, after incidenting like this, it got reflected back like this through the center of curvature, but actually came from somewhere here, and our image was formed somewhere here. This was A, B, A dash, B dash. Now we have got a virtual and erect image in this concave mirror. Where is our object placed? Between the principal focus and the pole. Now this length, what is it called? It is called the focal length. This length between the principal focus and the pole of the mirror is known as the focal length. What is the focal length of the concave mirror? Imagine this to be 15 centimeter. Now where should our object be placed? Just imagine in this case itself, just imagine this to be the mirror and all. Where should our object be placed? Where is our object? It is less than 15 centimeter. Less than 15 centimeter, or between, this is 0 centimeter and this is 15 centimeter, right? Between 0 centimeter and 15 centimeter our object is placed. So the range of distance of the object, this is the object, this is the image, right, of the object from the mirror to obtain an erect image is, what is the range? Just now I told you, between 0 and minus 15 centimeter. Okay, this should be the range. Okay, now we move on to our next question. What is the nature of the image? Let me just erase this so that it will be easier for you all to understand. Otherwise, it will become very much messy and there is no place here. The question is, what is the nature of the image? Of course, the nature is virtual and erect. And is the image larger or smaller than the object? Just now we saw in the ray diagram, it was larger than the image. So the size of image was larger than the object. And our final question, draw a ray diagram to show the image formation in this case. So that time I just drew a rough diagram. Let me draw it clearly for you so that you can understand. This is a concave mirror, rough surface. Always after drawing any mirror, draw the rough surface. The principal axis, pole, principal focus, center of curvature, and this is a focal length equal to 15 centimeter, right? And our object is somewhere over here between 0 and 15 centimeter. This is our object. First ray, incident ray, after reflection passes through the focus, comes actually for somewhere here, alright. This is our next incident ray, and after reflection passes back through the center of the curvature. Too many crooked lines because I don't have a scale over here. Let this just approximately, let this be the center of curvature, and this is the focal, this is the principal focus. Come somewhere from here, alright. The two dotted lines meet here, so this is our image. A, B, A dash, this is B dash. So here is our ray diagram. So now we move on to the next question. We have solved all the questions in question number 7. So after solving this, we move on to the next question. For solving the next question, question number 8, you should be thorough with the applications of mirrors or the spherical mirrors, right? You should be knowing which spherical mirror we use in which part of our life, alright. Only then you can move on to this eighth question, okay? The question is, name the type of mirror used in the following situations. And support your answer with reason. You should give the name of the mirror, plus you should support your answer why we use this particular mirror for this usage, alright. So the first one is number A, headlights of a car. Now for headlights of a car, which mirror do we use? We use concave mirror. We are asked to support our answer with a reason. Now the reason is, we had already gone through in our previous videos the usage of concave and convex mirrors. If you have any doubts, please go through those videos again. It's very well explained, especially in concave mirror. The reason is, as the concave mirror helps to produce a powerful parallel beam of light and has the property of convergence. Concave mirrors are used. This is the answer. As concave mirror helps to produce a powerful parallel beam of light and has the property of convergence. After writing the answer, you can underline this also. So your teacher doesn't have to go through the whole answer. Just read whatever is underlined. Powerful parallel beam of light and property of convergence. Enough. Your teacher will give you the full mark for this question. Now number B. Side or rear view of a vehicle. Side or rear view mirror of a vehicle. You guys must be very much familiar with this kind of mirror, because in every vehicle you see a side or a rear view mirror. Which mirror is used? This is a frequently asked question in CBSE boards too. The answer is convex mirror. And our reason is very much clearly explained in our NCERT textbook also. It gives, that means the convex mirror gives a wide field of view producing an image that is virtual, erect and diminished. This is the reason we use convex mirrors. It gives a wide field of view. It produces an image which is virtual, it's erect as well as diminished. It enables the driver to drive properly without any kind of accidents. It prevents accidents so that he can see whatever is there on the mirror. He can see whatever vehicles are coming, and accordingly he can drive. So in this way it prevents accidents. Next is number C. Solar furnace. In solar furnaces, we use concave mirror. The reason why we use concave mirror, mainly because of the convergence property. Concave mirrors have the property of convergence. They help to concentrate the sunlight to produce heat in solar furnaces. Since concave mirrors have the property of convergence, they can concentrate a large amount of heat in one particular place, that is in the solar furnace. They have to concentrate the sunlight, and when the sunlight is concentrated, heat is produced. In this way, concave mirrors, that's why the reason behind why concave mirrors are used is this answer. It has a property of convergence and helps to concentrate the sunlight so that heat is produced in the solar furnace. Large amount of sunlight is just concentrated in one area and heat is produced here. Alright. Okay, now we move on to the 9th question. You need a little bit of understanding for this question in question number 9. Very simple. Question number 9. The question is, 1/2 of a convex lens is covered with a black paper. Will this lens produce a complete image of the object? Verify your answer experimentally. Explain your observations. So this is a question. We have subdivisions. No, we'll be going with 2 cases. We have to verify our answer experimentally and we should explain our observations also. Okay. So 1/2 of a convex lens. What lens are we using? We are using convex lens and it is covered with black paper. Not fully, just 1/2 of it is covered. And now the question is, even if 1/2 is covered, will the lens produce a complete image of the object? Only half image will be produced. We have to verify it and explain our observation. So we'll be going with 2 cases. Okay. So case 1. Case 1. In this case 1, we will be covering the upper part of the lens. This is the convex lens. Okay. Then this is the optical center, F1 to F1. This is F2 to F2. Now we will be covering the upper part of the lens with a black paper. Okay. Let this part be covered. The shades show the black paper. Okay. Now this part is covered. Okay. This part is covered. Now we will be taking one object. Say over here between F1 and 2F1. This is A, B. Alright. Now the question arises, how would the refraction take place? Why not? The refraction can take place even if the upper half is covered. It will take place downways. Okay. Now the first ray goes like this. Then after refraction, it will go somewhere like this. Alright. This is a refracted ray. I take another ray which goes like this. Okay. And after refraction, it will go somewhere like this. This is a refracted ray again. The two rays meet over here. Okay, just the two rays meet over here. Why did I erase this 2f2 and write over here? Because remember, recall those ray diagrams. If the object is between f1 and 2f1, the image of the object should be beyond 2f2. So just be careful while drawing this kind of diagrams, okay? Or adjust your ray diagram whenever required. So the two refracted rays meet over here. Our image is formed over here. That's all. So even if one half is covered, refraction won't be stopped. But if the whole lens is covered, of course, refraction cannot be taken place. Suppose this is a convex lens and you cover the whole convex lens with a black paper. The convex lens is no more transparent. It becomes opaque. So refraction cannot take place through opaque objects, right? So refraction cannot take place if the whole lens is covered. Since only one half is covered, the object gets a chance to form image through the down part of the lens, because here it's not covered by any black paper or it's not being opaque over here, right? So in this case, a ray of light coming from the object is refracted by the lower half of the lens. These rays meet each other at the other side of the lens, means at this part, not at the same side, at the other part of the lens, and they form the image of the object in this way. Alright, now we take case 2. In case 2, what we will be doing is that in this case 1, what we did, we have covered the upper part of the lens. In case 2, we will be covering the down part of the lens. See, after drawing the ray diagrams, just write your observations, okay? Don't leave it as such. Case 2. This is a convex lens. This is the lower part of the lens, okay? So this lower part of the lens, I am covering it with a black paper. This is the optical center O. This is my f1 to f1. Then this is f2. Let it be straight. This is 2f2. I'm taking my object again over here. Say this is A and this is B. Now, the refraction takes place like this. This is my ray, the first incident ray. Then after refraction, it passes through F2. This is a refracted ray. Now the next ray passes through the optical center and goes somewhere like this. So both the rays meet this way. Let this be 2f2, okay? Just adjust the ray diagram. So both the rays meet over here and our image is formed over here. So this is A, then this becomes A dash, this is B, and this becomes B dash. So our image is formed finally. So what can you say after seeing this? In this case, a ray of light coming from the object, this is the object, it is refracted by the upper half of the lens, and the rays, the refracted rays, all the refracted rays, they meet together on the other side of the lens to form the image of the given object. So therefore, the convex lens will form a complete image of the object even if one half of the lens is covered. Even if the lens is covered, like one half was covered, the image formation will not be stopped by the lenses. So I end my video over here. If you have any doubt, do ask me in the comment section, or if you want me to make a video from any topic, from any subject, just mention in the comment section. Thank you.